Let's consider the following problem. A set of double 6 dominoes consists of 28 dominoes. Each domino has 2 ends with 0 to 6 dots on each end, and every possible combination occurring on exactly one domino. For example, there is exactly one of the dominoes shown right here, which has 3 dots on one side on the left and 1 dot on the other side. How many total dots are there in all 28 dominoes? So how can we solve this problem? Well, the straightforward solution is just to count all the dots on all the dominoes. There's not that many dominoes, not many choices, so we probably can handle this thing pretty fast and easy if we do this counting in a smart way. So first, let's consider dominoes that have a 0 on one side, right here. Well, we're going to have 7 dominoes like this, and those are the dominoes that have the numbers 0 through 6 on the other side. Now, if we take all the 7 dominoes and ask how many dots there, well, it means to calculate the number of dots, we simply need to add numbers from 0 to 6, right, and be done with them. Now, let's just look at this sum and figure out how to add those numbers quickly. Obviously, you could just simply do it in a straightforward way, 1 plus 2 plus 3 plus 4, and so on. How would we do it easier? So, well, let's first notice that 0 doesn't do anything for us, so we get rid of it. Now, for the other numbers, let's add the numbers at the edges. 1 and 6, we get 7. Now, let's add the numbers next to them, which is 2 and 5. Again, we get 7. Let's add the numbers next to 2 and 5. It's 3 and 4. Again, we got 7. So we got 7 3 times. The answer is 21. Easy. Now, the other way to solve this problem is to notice that those numbers we have here, 0, 1, 2, 3, 4, 5, 6, are the terms of arithmetic sequence or arithmetic progression. So, and there's a well-known formula for the sum of terms of arithmetic sequence. So if we consider A1, A2, AN are n terms of the arithmetic sequence, their sum is simply the first term plus the last term multiplied by the number of the terms and divided by 2. Okay. Again, either way is fine. Either way gives you the same answer. So we found now that there are, if you just count the dots on the dominoes that have 0 on one side, we're going to count 21 dots. Now, okay, we counted the dots on the dominoes that have 0 on one side. What about the ones that have 1 on one side? Well, again, we probably tempted to say, well, on the other side, we're going to have numbers 0 through 6 again, right? In this case, we have to add again 0 through 6, and also we need to remember that we need to add 1 for each of the dominoes. That seems to be like the way to go, but we have to be very careful, because if you start from 0 on the right side, we're going to count a domino that looks like this, 1, 0. But this domino is exactly actually the same domino as domino 0, 1. Okay? It just flipped. And we were told in the problem that there's only one domino like this. And we already counted this domino, right, when we counted the dominoes that have 0 on the left side. So what it means, if you want to avoid double counting, we have to skip 1, 0. In this case, we have to start with 1 and go to 6. Okay, so the dominoes we need to consider is dominoes that have 1 through 6 on the right. For each of that number, they're going to be 1 on the left. So if you look what the sum of the dots on each dominoes, the sum of the dots is going to be from 2 till 7. So we need to add numbers from 2 till 7. Okay. Well, we can use either of these techniques as we talked about before. It's an arithmetic sequence. We can use this formula, or we can just add the numbers at the edge and do it this way. But either way you do it, you get number 27. Okay. All right. We count the dominoes with number 1 on one side. What about if there's number 2 on one side? What's happening here? Again, if you want to avoid double counting, we should not consider the case 2, 0. We already look at it here. We also shouldn't consider the case 2, 1. We already look at it here. So we should start with 2 and go to 6. So in this case, we're going to have domino 2, 2, which has 4 dots. We have domino 2, 3 that's going to have 5 dots, and so on. And the last one, we have domino 2, 6 that has total 8 dots. So we're getting numbers from 4 till 8. Again, using any technique you want, you get number 30. That's how many dots we have. Next, we go for 3. When we do 3 again, so we don't want to double count. In this case, we need only consider 3 through 6 on the right side. It means that we need to add numbers 6 through 9, number of dots. And that's 30 again. Next going to be 4. In this case, we consider 4 through 6 on the right side. Add those numbers, we get 27. 5. In this case, we consider on the other side 5 and 6. It's 10 and 11, which is 21. And the last one, we need to consider 6, 6. And that's obviously 12. Well, and the last thing we need to do, we need to add all these numbers. Notice there's 21 here, 21 here. There are 2 21s, 2 27s, 2 30s, and 1 12. If you add them together, you get 168. And that's the solution to the problem. Now, this way, we actually went and meticulously calculated the number of the dots for all the dominoes, okay, in some systematic way, but still we have to go through all of them and calculate separately for 0 on the left, 1, for 2, for 3, for 4, for 5, for 6. Now, is there a way not to do this? Maybe simpler? Well, maybe not. But anyway, there is a way. Let's look at that one. And then you can be a judge and see which way you like better. So, first what do we do? As before, we pick up all the dominoes that have 0 on one side. On the other side, we're going to have 0 through 6. If we add all the dots, we get 21, right? We already done this. Now, let's take this dominoes and put them back in the bag. And now pull all the dominoes we see, or we can find, that have 1 on one side. Obviously, on the other side, we can have 0 through 6, right? Well, in this case, you may start telling me, wait a second. You double counting, right? Did we do calculations before, and we did it in a very precise manner, very careful, so we don't do double counting? No, that's what we did last time. This time, I'm not doing it. Yes, I'm double counting, but I want to do it now. I want to do it this way, and what I'm going to do at the end, I'm going to really take care of this double counting, okay? So, okay, so if I choose 0 on one side, there's 0 through 6 on the other side. I can choose 1 on one side, there's 0 through 6 on the other side. I can choose 2 on one side, again, 0 through 6 on the other side, and I can keep going, okay, through all of them, okay? So for each number on the left, there are 7 dominoes that give you 0 through 6 numbers on the right, okay? Now, the way we're going to count dominoes this time is, well, we're going to count the dots on the left, on the right first, and then we're going to count the dots on the left. So if you look at the number of dots on the right, each time we have dots going from 0 to 6. Well, we need to add numbers from 0 to 6. We know that answer is 21. So they're going to be 21 dots here on the right, 21 dots here, 21 dots here, 21 dots here, and so on. So it means that on the right, we're going to have 21 7 times. Okay, we got the right side. Now, in a similar manner, we would like to, on some manner, we would like to calculate the dots on the left. Well, one thing you can say, hey, there's full symmetry on the left and on the right. So whatever number of dots we have on the left, same should be on the right. So, and vice versa. So on the left, we should have 7 times 21, right? Now we can do it this way, or if you don't believe me, we can, honestly calculate everything. Notice, in each of this group, I have 7 dominoes, right? So if I want to count the number of dots on the left, in the first group is going to be 7 times 0. In this group is going to be 1 times 7, right? 7 times 1. Here I'm going to have 7 times 2. Here I'm going to have 7 times 3, and so on, right? So if I want to calculate the total number of dots, I just need to add those numbers. 7 times 0, plus 7 times 1, plus 7 times 2, and so on, plus 7 times 6. Now notice each term has 7 here. We can pull it out. And now look at what we have here in parentheses. It's our favorite sum, and we know it equals to 21, right? So that means that on the left, we also have 7 times 21 dots. All right. So, and how many dots we have in total? What we have on the right plus what we have on the left, it's 14 times 21. And now we got to this point and say, well, wait a second, we had double counting, so probably we just need to divide this number by 2, and we get the real answer. But again, we have to think a little bit. Did we double count everything? Well, we definitely double counted numbers like this, or dominoes like this. Domino 4-1 was counted when we counted these guys, 4 on the left. Domino 1-4 was counted when we look at dominoes that have 1 on the left. But those dominoes are dominoes that have different numbers on the left and on the right. Those we did double count. But the dominoes that have the same number on both sides, left and right, we did not double count. We counted them only once. So those dominoes like 0, 0 on both sides, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. All right? So now, when we look at this number 14 times 21, it really comes from this formula. Now, what does formula mean? First of all, this subscript xy, by subscript xy, I denote the dominoes that have different numbers on left and on the right. By index xx, I denote the dominoes that have the same number on both sides. Okay? And nxy is the total number of dots on the dominoes that have different numbers on the left and on the right. And xx is the number of dots, total number of dots, on the dominoes, all dominoes, that have the same number on the left and on the right. Okay? This is what we have, but this is what we want. We want to have, don't want to have this 2 here. We want to have 1 here. So how do I find this if I know things like this? So let's think about it. And really the solution to this problem is to find this number of dots on all dominoes that have the same number on the left and on the right. Well, how do we do this? Well, let's count them. Here they're all. Now, look, probably the easiest way to count, if you count the left separately from the right. On the left, we have numbers 0, 1, 2, 3, 4, 5, 6. We need to add them up. We get 21. And same thing on the right. We also get 21 dots on the right. So total, we're going to get 2 times 21, or 42, right? So now what we're going to do is simply substitute this number right here. This is what we're going to get. Then we want to get rid of 2 times 21. To do this, we subtract it from both parts of this equation. Now we're going to have 12 here instead of 14. We subtracted this 2 times 21. And now, since we're interested in 1 and xy, we have to divide it by 2 and get 6 times 21. So now we got the answer, really. We're interested in some of these guys. The first guy is this. The second guy is this. We just need to add them up. We get 8 times 21, or 168. And that's it. So you see two different ways to calculate the number of dots on dominoes. Both ways give us the same answer. Obviously, they have to. And it's up for you to decide which way is easier.